Welcome back to another one of my implicit differentiation videos. This one will be the second video on implicit differentiation with graphs. I'm not going to be doing anything with the graphs, I'm just going to be showing you a graph just so you can get an idea of what we're actually doing a bit better, or you can see it from a different point of view. Anyway, I'll get right onto it. So just before I start, I will be taking examples from this book, James Stewart Calculus. The copyright is on the bottom if my camera can focus. Anyway, it's Sengage Learning. I'm probably shredding that name, but that is the name it says. I'll put it in the description, but that's the book I basically use for all my calculus. And first example today, I'm not going to draw it because it's going to be, I've tried drawing it and it doesn't work. I'm just going to show you what it looks like. It's going to be this one right here, and that's the formula there. So we're going to, once we found the derivative of this and we put in a y and an x of whatever of these, then we'll be able to find the slope at any one of these points, which is pretty funky. So let's get right onto it. So example 1. It said that it was cosine of x minus sine of y equals sine of y minus sine of x. Okay, so just like usual, find the derivative of both sides. I'm not going to rewrite it, I'm just going to use quotation marks to signify. Okay, so let's find the derivative using the chain rule. So the derivative of the outside of this one is negative sine. The inside stays the same. And then we multiply it by the derivative of the inside. Derivative of x is just literally derivative of x. Goes back to x minus sine y, which the derivative of sine y, so negative sine goes to negative cos y. Inside derivative of y, which is the inside, it's just derivative of y. And I'm not going to run out of room, so I'm just going to go down here, which equals this side, which is the derivative of sine, it's cos y minus sine x, multiplied by the derivative of y, which is just the derivative of y, minus derivative of sine, which is just cosine x, derivative of the inside is just dx on dx, oh shit, and then you got your bracket to finish it off. Okay, now what we're going to do is we're going to expand this into this and this into this. So negative sine of this multiplied by dx, that's 1, so it just stays the same. Now we're multiplying negative sine of this onto negative cos of y, which will come out of dy dx, so that'll be a positive because negative times a negative. I'll put the dy dx out the front, multiplied by, I'll put the cos first, cos of y, sine of x minus sine y. And that will equal, I'll expand this out, the cos of this multiplied by the derivative is just the derivative multiplied by the cos of that. Okay, now cos of this multiplied by negative cos x is going to be negative cos x multiplied by cos y minus sine, oh god, That's sine x, by the way, very small. Okay, so now we've got this all expanded out. We can rearrange it. Okay, what I'm going to do here is I'm going to say that x minus sine of y equals h, and y minus sine x equals g. I'm only going to say that because this is starting to take up heaps of room and I don't want to have heaps of room being taken up. So, negative sine is going to be h plus the derivative respect to x multiplied by cos y multiplied by sine, that's x minus y, which is h, equals the derivative of multiplied by cos of g minus cos x multiplied by, I'm not going to be able to fit this either, cos y sine x is going to be g. Okay. Because everything inside the brackets doesn't get affected at all, and it makes it, it cleans it up a little bit. I still couldn't fit it in because I started too big up here. But anyway, so let's get all the normals on one side and all the dy dx multiples on the other side. Okay. So I'm going to keep negative sine h on this side, and I'm going to move negative cos x cos g on this side. So it's going to look cos x multiplied by cos g minus sine h equals the derivative of cos g, not of, it's just the derivative multiplied by, minus the derivative multiplied by cos y sine h. Okay, so we've got all the derivatives on one side and all the non-derivatives on the other, or non-multiples of the derivative. Okay, so this side stays the same. Just use quotation marks to signify that. But here we'll factor out the dy dx, so we isolate the derivative, and we're left with cos g minus cos y sine h. What we're going to do now is going to get this and divide it on both sides, which will bring this on top of that. I'll write that out if that doesn't make sense. Okay, that is your derivative. I'm going to fill these h's and g's back in. Okay, so we said that it's going to be cos x multiplied by cos of g. We said that g was y minus sine x, and then we have minus sine of h. We said that h was x minus sine y, all over cos of g. We said that g was y minus sine x, minus cos y multiplied by sine h. And we said that h was x minus sine y. And that all equals the derivative. Alright, so just to clarify, that there is, we'll get, if we put in an x and a y point, we'll be able to tell the slope anywhere on this graph. Alright, thanks for watching. I hope you learned something and have a good day.